Okay, for tutorial 7, heat transfer in pin promoters. Pin promoters of the type shown in figure 1a and b are used in heat exchangers to enhance heat transfer by promoting local wall turbulence and by extending heat transfer area. Derive the differential equation to compute the temperature profile assuming temperature varies in the x direction. The plate temperature, EB, the fluid temperature, TA, and the heat transfer coefficient, H, are constant. Okay, so we are told to derive the differential equation, okay, of the temperature profile. So this is your pin promoter and this is the side view of one of the pin, okay? So over here, you have your convective heat transfer between the fluid and the object as well. Now, let us get into solving the problem. Okay, do it here. So we take the x, sorry, okay. So we take x at the pin tip, okay, as such. So we should take this one as x, okay, coming down over here, okay. At the pin tip for geometric simplicity, okay, similar triangle. So the heat is conducted along the pin axis and is lost through the perimeter of the incremental area, okay. So the incremental area AS is 2 pi y delta S. You need to say if we look at from the top, oops. Okay, if we look at from the top, this would be your delta S, okay? So the steady state conversion law is negative QXA at x plus delta x, okay, minus, because we are going downwards, the x is going downward, that is why it is negative, minus negative QX area at x minus the convective heat transfer between the fluid and object, which is H 2 pi y delta S T minus TA equals to 0. So we should take note that y over x is equals to b over h. Okay, meaning to say, so you have your y over x is actually your b over h. Okay, it is a similar triangle. Okay, and then delta s, okay, not this way. So cos beta, okay, we look at this triangle here. So this is your beta, so meaning to say this angle is also your beta. We take it out. This is your beta angle. This is your 90-degree angle. So cos beta is equals to adjacent over hypotenuse. So it is delta x over delta s. Therefore, delta S is delta x over cos beta. Okay, so from here we know that y is b over h multiplied by x. So we substitute this and this into this equation to substitute y and delta s, which is here. All right, so that leaves us with negative qxa plus delta x plus, okay, negative becomes plus qxa at x minus 2 pi hb x delta x and h cos beta t minus ta equals to 0. So we divide everything by delta x and take limit as delta x approaches 0, and take limit as delta x approaches 0, we should get negative d qxa over dx minus 2 pi hb capital H cos beta x multiplied by t minus ta equals to 0. So we know that q is equals to negative k dt by dx, and the area should be pi y squared, which is also equal to your y. You substitute your y that we have derived, b over h x squared. Okay, we can take the x out, so it becomes x squared. Therefore, we should obtain negative d over dx. So q and a, we put it in, negative k dt over dx multiplied by the pi x square b square h square minus 2 pi hb over h cos beta x t minus ta equals to 0. Okay. Now, after simplification, okay, after simplification, we should get d over dx k pi b squared over h square x square multiplied by dt dx minus 2 pi hb over h cos beta x t minus ta equals to 0. And then we multiply everything by h square over k pi b square. So because this is a constant, so this one can be taken outside here. So when we multiply this one will be cancelled off. Okay. Then so your pi will be cancelled off also. Your b, one of the b will be cancelled off, and your h will be cancelled off also. Therefore, we will end up with this equation d dx x squared dt dx minus 2hh over kb cos beta x multiplied by t minus ta equals to 0. So we take, okay, we will take theta to be t minus ta to simplify it, and this whole section to be lambda. Therefore, from here, because we input a new variable in, which is a function of it, so d theta is equals to, so this is equals to 1, therefore, over dt, d theta over dt equals to 1, which leaves us with d theta is equals to dt. So we can substitute after we change the variable. So we get d over dx multiplied by, change this one to theta, dx equal minus lambda x theta equals to 0. So we can simplify this. This one can be taken out. So this one becomes x squared d squared theta over dx squared plus 2x d theta dx sorry, this is your product rule, okay, and then minus lambda x theta equals to 0. Now we take this one to be z, okay, so lambda x equals to z, therefore x is equal to 1 over lambda z, and dz over dx is equals to lambda, right? So dz is equals to lambda dx. Dz, write it here. Okay. Again, we put this thing in. We're changing variables again. Here's my mouse. They substitute it in, whereby x squared d dx multiplied by d theta dx plus 2x d theta dx minus x lambda theta equals to 0, right? So we get z over lambda square. This is what we have set here. And dz dx multiplied by so this one, when you cut it off, so this part is this section over here, yeah, and plus 2, your x is z over lambda multiplied by d theta over dz multiplied by dz over dx. So this one is also, this part here is this one, this section here, minus z over lambda multiplied by your lambda theta equals to 0. So we simplify the equation and we should get okay, so this one is lambda, right? Dz over dx is lambda, okay? And over here we also have dz over dx, so this is lambda, and 2 dz over dx, yep, this is also a lambda. Okay, so basically this one can be cancelled off, this one can be cancelled off with this one, this whole thing is your lambda. Okay, this one is not a function of z, so we can take it out, and this 2 will be crossed off with this square, lambda square, and we will get the final answer as z square d square theta over dz square plus 2z d theta over dz minus z theta equals to 0. Okay, so that's all for tutorial 7.